Hello and welcome to All Maths Considered. In this video, we are going to look at a problem from St Petersburg Mathematical Olympiad from the year 2002. The problem is as follows. Let us consider an array of numbers with 5 columns and 37 rows. And let us say we have the numbers 1 through 10, which are ended in this table, subject to the following two conditions. Condition number 1, in each row, the numbers do not decrease. So for instance, you may have a row 5, 6, 6, 9, 10, something like that. And the second condition is that in each diagonal going this way, so northwest to southeast, some of them may be shorter, we're allowing shorter diagonals as well. In each such diagonal, the numbers are the same. In each diagonal going this way, the numbers are the same. The problem then is to prove that there exists a row where all the numbers are the same. So I suggest that you now stop and try to solve this problem by yourself. In a short while, we'll proceed and give a hint for the solution of this problem. As a hint, I suggest that you look at the numbers specifically in this table, standing in the first column and in the first row. So look at these numbers. Again, I suggest that you hit the pause and try to solve the problem if you didn't solve already by using this hint. See how this could be useful. And in a short while, we'll give a solution for the problem. So let us now proceed with the solution. So let, as provided by the hint, look at the numbers in the first column and in the first row. So the total of these numbers is 37 in the first column and of course 5 in the first row. Together that would be 42, but one number is counted double. So we don't count double, we have 41 numbers. So let us number them, A1, A2, and so on, A37, and then A38, and so on, A41. So we have numbers A1, A2, and so on, A41. So now it is easy to see that this sequence of numbers is non-decreasing. And actually the last portion, it's easily non-decreasing because that's just the first row. But even in the first column, if we have two numbers going up, if we look at some section and we have a number AK and below it AK minus 1 in the first column, then the number here is AK as well. And since they do not decrease in the row, they will not decrease in this column as well going up. So we will have AK minus 1 less or equals an AK for any k. So now we have a non-decreasing sequence of numbers. The numbers are from 1 to 10 and we have in total 41 numbers. So each number from 1 to 10 just occurs somewhere in the sequence, and once it occurs, it may occur a few times, and that's really it. It cannot occur before and it cannot occur again after that. It will just occur as a certain number of copies somewhere. And since we have 41 numbers and we have 10, there must be some number out of 10 which will occur more than 4 times. Otherwise, we would have a total of 40 numbers at most, and we have 41. So there will be a number which occurs at least 5 times. So if this is a sequence, let's call the sequence L. So some number repeats 5 times, at least 5 times in the sequence L. But that's really it, because if we do have a section somewhere in this sequence which repeats 5 times, just follow the diagonals with this number. So you can follow the diagonals down. And if you have somewhere a section 5 numbers which repeat, then they will, by following the diagonal, we will have a row where these numbers will be the same. So we see that we will find a row where all the numbers are the same. Now in this problem, of course, we have specific numbers 1 to 10, and then 5 rows and 37 columns. And then if you're interested in this, you can think about it, how to replace 1 to 10. Let's say you replace 10 by K and replace 5 here by M. And then the question is, what should be in place of 37? How many rows do we need so that we can guarantee that one row will have the same numbers? And that's the solution of this problem.